What is a projectile motion? The projectile motion is defined as the form of motion that is experienced by an object when it is projected into the air, which is subjected to the acceleration due to gravity. The projectile is the object, while the path taken by the projectile is known as a trajectory. Defining a projectile. A projectile is an object upon which the only force acting is gravity. There are a variety of examples of projectiles. An object dropped from rest is a projectile, provided that the influence of air resistance is negligible. An object that is thrown vertically upward is also a projectile, provided that the influence of air resistance is negligible. And an object which is thrown upward at an angle to the horizontal is also a projectile, provided that the influence of air resistance is negligible. A projectile is any object that once projected or dropped continues in motion by its own inertia and is influenced only by the downward force of gravity. By definition, a projectile has a single force that acts upon it, the force of gravity. If there were any other force acting upon an object, then that object would not be a projectile. Thus, the free body diagram of a projectile would show a single force acting downwards and labeled force of gravity, or simply F-graph. Regardless of whether a projectile is moving downwards, upwards and rightwards, or downwards and leftwards, the free body diagram of the projectile is still as depicted in the diagram at the right. By definition, a projectile is any object upon which the only force is gravity. Following are the formula of a projectile motion, which is also known as a trajectory formula.
Formula.
Problem number 1.
A rock is thrown horizontally of a 100-meter cliff. It lands 90 meters away. At what speed was it thrown? First, we need to draw a diagram based on the problem. In the vertical or y-axis, given A or the acceleration is equals to 9.8 meter per second or the gravity. The initial velocity or the original position of the rock is 0. Y, which is the height of the cliff, is 100 meters. And the initial velocity is 0. And the equation we are going to use is y is equals to y initial plus initial velocity times time plus 1/2 times acceleration times height squared. But the value of the y initial and initial velocity is 0. Therefore, we are going to cancel the two. And the final equation that we are going to use is 1/2 times acceleration times time squared. Then we are going to simplify it, which is time is equals to square root of 2 times y over a. Then we are going to distribute the respective value. T is equals to square root of 2 times y, which is 100 meters over a, which is 9.8 meter per second squared. Therefore, the value of the time is 4.52 seconds. After getting the time in the vertical, we are going to get the value of initial velocity on the horizontal or x-axis. Given is x of 0 is equals to 0. Acceleration is 0 because there is no gravity in the horizontal. Then time is equals to 4.52 seconds. And the initial velocity is missing. The equation that we are going to use is x is equals to x sub 0 plus initial velocity times time plus 1/2 acceleration times time squared. But then, the value of x sub 0 and acceleration is 0. Therefore, we're going to cancel the 2. Then, the final equation that we get is initial velocity times time. But then, initial velocity is our missing value. Then, we are going to simplify the equation. The equation that we are going to use is initial velocity is equals to x over time. Then we are going to distribute the value of the 2. Initial velocity is equals to 90 meters, which is the x over 4.52 seconds for the time. Then the value of initial velocity is 19.91 meter per second.
Problem number 2.
A soccer ball is kicked horizontally off a 22-meter high hill and lands a distance of 35 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. First, we need to identify the given information of the problem, which is the horizontal info. X is equals to 35 meter, AX is equals to 0 meter per second, while the vertical info, Y is equals to negative 22 meter, Vy is equals to 0 meters per second, and the AY, which is the gravity, is equals to negative 9.8 meter per second square. Then, for the solution, we use y is equals to VIY multiplied by t plus 0.5 multiplied by a sub y multiplied by t squared to solve for the time, which is the time of flight is 2.12 seconds. Now, use x is equals to VIX multiplied by t plus 0.5 multiplied by a sub x multiplied by t squared to solve for VIX. Note that a sub x is 0. meter per second squared, so that the last term on the right side of the equation cancels. By substituting 35 meter for x and 2.12 second for t, the VIX can be found to be 16.5 meter per second.